Hi everyone. Now we are going to see about Quine-McCluskey method or tabular method. The Quine-McCluskey method is used to reduce the number of logic variables in the given function. As already we have discussed in the previous lecture videos, we reduce the given function using Boolean algebra and also by using K-map. The third method is Quine-McCluskey method or tabular method. In this method, there are totally 5 steps. First step is we are going to write the binary representation for the given function. As given function is 0, 2, 3, 6, 7, 8, 10, 11, 12, 15. So the binary representation of 0 is 0, 0, 0, 0. For 2 is 0, 0, 1, 0. For 3 is 0, 0, 1, 1. For 6 is 0, 1, 1, 0. For 7 is 0, 1, 1. For 8 is 1, 0, 0. For 10 is 1, 0, 1, 0. For 11 is 1, 0, 1, 1. For 12 is 1, 1, 0, 0. For 15 is 1, 1, 1, 1. So, first the binary representation for the given function is given in the table. Next step is we need to form the grouping of ones. First, the 0 ones is grouped. Second, one single one is grouped. Third, 2 ones are grouped. Next, 3 ones are grouped. Next, 4 ones are grouped. So, grouping of ones. So, in 0, it consists of 0 ones. So, 0 is the min term for the 0 ones. In the case of single ones, 2 and 8. So, in 2 and 8, 2, 0, 0, 1, 0. In 8, 1, 0, 0. For grouping of 2's, in 3, 0, 0, 1, 1. 6, 0, 1, 1, 0. 10, 1, 0, 1, 0. 12, 1, 1, 0. In the case of 3, 7 and 11 are grouped. For 7, 0, 1, 1. For 11, 1, 0, 1, 0. 1, 0, 1, 1. In the case of 4, 15 is grouped. So, for 15, 1, 1, 1, 1. So, as in the case of zeros ones, the min term is 0. As in case of single ones, the min terms are 2 and 8. As in case of 2 ones, the min terms are 3, 6, 10 and 12. As in case of 3 ones, the min terms are 7 and 11. As in case of 4 ones, the min term is 15. So, the step 1 is first binary representation for the given function. Step 2 is grouping of ones. Step 3 is two-cell combination. In the two-cell combination, we are going to compare 0 with zeros ones with single ones grouping, and single ones groups with the 2 ones grouping, and 2 ones grouping with the 3 ones grouping, and 3 ones grouping with the 4 ones grouping. So, we are going to reduce the table by combining the zeros and with the single ones. As in case of first combination 0 and 2, here there is a single change in the third bit. So, remaining bits are same. Remaining bits are 0, 0, 0. The third bit is a single change. Here, so 0, 0, dash 0. As in case of 0, 8 combination, the first bit is a single change. Here, there is a change from 0 to 1. The remaining bits are same. As in case of next combination is 2 ones, single ones with the 2 ones. So, as in this case, we are going to check with the combination of 2 with 3. Here, the fourth bit is a single change. The remaining bits are same 0 0 1 dash. Then next 2 with 6. Here the second bit is a single change, so 0 dash 1 0. As in case of 2 comma 10, the first bit is the single change, remaining bits are same. As in case of 8 comma 10, the third bit is a single change, so dash, so remaining bits are same 1 0 hyphen 0. As in case of 8 comma 12, the second bit is a single change, remaining bits are same 1 hyphen 0 0. As in case of 3 comma 7, so 0 hyphen dash, then remaining bits are same. So as in case of 3 comma 11, dash 0 1 1. So as in case of 6 comma 7, 0 1 1 dash. As in case of 10 comma 11, 1 0 1 dash. As in case of 7 comma 15, dash 1 1. As in case of 11 comma 15, 1 dash 1 1. So here we are going to check the possibilities of single one changes from one minterm to another minterm. We are going to check the combination between two minterms. Only the single one changes will be taken into the combinations. So by this we have formed the groupings like this: 0, 2, 0, 8, 2, 3, 2, 6, 2, 10, 8, 10, 8, 12, 3, 7, 3, 11, 6, 7, 10, 11, 7, 15, 11, 15. These are all the possible combinations with the single change of 1. Next, we are going to form the 4 cell combinations. So, next we are going to reduce the number of states by reducing the combinations. Next, in the previous step, we checked with the single one change, single bit change, either 0 to 1 change or 1 to 0 change is taken into the consideration to form the 2 cell combination. Here also the same with single dash. We are going to check with the single dash combination and also with the only single change in the binary representation, either 0 to 1 change or 1 to 0 change. So in this combination we checked with the 4 cell combination. So we formed the grouping. It's like 0, 8, 2, 10. So we are checked with 0, 8 and 2, 10 combination. Then dash 0 dash 0. Then combining the 2, 10 with 3, 11 dash 0 1 dash. Then combining 3, 11 7, 15 dash dash 1 1. Then we are going to combine the 2, 6 with 3, 7. So 0 dash 1 dash. So the same thing we are going to check with this. In the previous 2 cell combination, 0 to 1 change, otherwise 1 to change, 0 change is taken into consideration. Here in 4 cell combination also the same with the single dash. Next we are going to form the prime implicance table. So in the prime implicance table, first we need to write the combinations, then we need to put the cross mark, X mark in the minterms. So in the case of 0, 8, 2, 10, so 0, 8, 2, 10, we need to put the cross mark in the 0th term, 2nd term, 8th term and the 10th term. In case of 2, 10, 11, 3, you need to put the cross mark in the 2, 3, 10, 11. In case of 3, 7, 11, 15, we need to put the cross mark in the 3rd one, 7th one, 11th one and 15th one. In case of 2, 6, 3, 7, you need to put the cross mark in the 2, 6, 3, 7. So next is we need to find the prime implicance value. In the prime implicance value, so all the minterms are covered in this combination, prime implicants combinations. So the single x is taken into the consideration. So consider the single x. We need to get the values as 3, 7, 11, 15. For the prime implicants 3, 11, 7, 15, the value is here CD. So the value is CD corresponding to the 3, 7, 11, 15. So we need to check only the single x in the corresponding minterms. So the first one is 0th minterm only having the single x, and 15th minterm has only single x, and 6th minterm having only single x, and then 12th minterm has having only single x. So considering this one, so first one is CD. Next is for considering 0, 8 to 10. In this case, so B bar, D bar. So in this case, the corresponding minterm variable is B bar, D bar plus CD. For considering 2, 6, 3, 7. In this case, 2, 6, 3, 7. The corresponding variable is A bar, C. Next, the 8 and 12 are the terms which is not covered in the prime implicants. So 8 and 12 are taken into the consideration. So considering 8 and 12 in the prime implicants, so we are putting the cross mark in the 8 and 12. For 8 and 12, the single x is in the 8, 12. The corresponding term is in 8, 12 is A, C bar, D bar. So it is taken it into the Boolean expression. So we need to consider the first write the prime implicants and find out the essential prime implicants and find out the missing terms in the minterm and find out those minterms and write the corresponding variables according to this min terms. So this is how we need to reduce the given function by using Quine-McCluskey or tabular method. In this problem, we have discussed about how to solve the given function using Quine-McCluskey method. So now we are going to discuss the same problem with the don't care condition. In this problem, the don't care condition is not mentioned in this problem. So now we are going to see about the same problem with the don't care condition. So same 5 steps we are going to repeat it again here. So for the given function, first write the binary representation for the given function along with the don't care. Here the don't care is represented with the symbol star in the subscript, superscript. So number of first we write the binary representation for the given terms. Next we are going to form the groupings. As in the groupings, first we need to group the zeros ones, then single ones, then 2 ones, then 3 ones. So first write the binary representation and then form the groupings as zeros ones. In zeros ones there is no zeros ones, so put a hyphen for this. Then single ones. In this case 1, 4, 8 are the single ones. As in case of 2 ones, 3, 5, 9, 10, 6 are the 2 ones. As in case of 3 ones, 11 is having the 3 ones. Second step is forming the number of single ones as a groups. Next step is to form the 2 cell combination. The same steps we are going to repeat it again here. We need to check the combinations with the single ones and 2 ones. So single ones are 1, 4, 8 with 2 ones. So 1, 3. Here both the variables are the same. The third bit is a single change from 0 to 1. So the remaining bits are same. So there is a change in the third bit alone. So 0, 0, dash 1. In 1, 5 there is a change in the second bit alone. So 0 hyphen 0, 1. In 1, 9, so the remaining bits are same. So hyphen 0 0 hyphen. So in the case of 4 comma 5, the remaining bits are same. There is a change in the only in the fourth bit. In 4 comma 6 also there is change only in the third bit. In the 8 comma 9 there is only small change in the fourth bit. In 8 comma 10 also there is a small change in the third bit. So in 3 comma 11 there is a small change in first bit, remaining bits are same. In 10 comma 11 there is a small change in the last bit. In 9 comma 11 there is a small change in the third bit, remaining bits are the same. By using this, first we need to form the two cell combinations. So in the two cell combinations there is a single change from 0 to 1 change or 1 to 0 change is taken into the consideration. The two cell combination is formed. Next is to form the 4 cell combination. In 4 cell combinations we need to check with the single dash and also single change. So as in this case 1 comma 9 comma 3 comma 11 is taken into the consideration. So hyphen 0 hyphen 1. Then 9 11 8 comma 10. In this case 1 0 hyphen hyphen. These are all the 4 cell combinations to form the minterms. So next is to form the essential prime implicants and then prime implicants. So as in case of prime implicants, first we need to put the cross mark in the corresponding minterms. So in the corresponding minterms 1 comma 3 comma 9 comma 11, put the cross mark in 1 3 9 and 11. And in case of 9 11 8 10, put the cross mark in the 9 10 11 8. So here we won't consider 8 because 8 is a don't care variable. So we no need to put cross mark for the 8. Only the minterms are taken into consideration. We won't bother about the don't care minterms. So remaining terms which is not covered in this prime implicants are 4 comma 5. So next is you need to check with the 4 comma 5. The 4 comma 5 is the values are 0 1 0 hyphen. So next we are going to put the values as 0 1 0 hyphen. Next we are going to put the cross mark in the 4 and x. Next we are going to form the grouping. So as in the case of grouping, so for 4 comma 5 the value is a bar b c bar. So this is the variable for this prime implicant. So for 4 comma 5 a b bar a bar b c bar. So for 1 comma 3 comma 9 comma 11 the prime implicant value is, so we need to check with this. So here b bar, b is 0, b bar d. So b bar d, first term is b bar d and the second term is 9 comma 11 comma 8 comma 10. For this term a b bar. So next is a b bar. So the missing term is 4 comma 5. For the 4 comma 5 we need to check with this two cell combinations. Here a bar b c bar. So next we are going to write a bar b c bar. So by using this we have reduced the given function by using the Quine-McCluskey or tabular method. So we are going to summarize the Quine-McCluskey method. Here in this lecture video we have discussed two problems for the Quine-McCluskey method. First problem is without don't care condition and second problem is with don't care condition. So there are 5 steps. First step is we need to write the binary representation for the given function. Second step is to form the grouping of ones, zeros ones, single ones, 2 ones, 3 ones and 4 ones. Third step is you need to form the two cell combinations and the fourth step is you need to form the 4 cell combinations and the fifth step is we need to form the prime implicants. In the prime implicants we need to put the cross mark in the each variables and we need to find out the essential prime implicants with a single cross. So finally we are going to write the expression by using the essential prime implicants. Thank you.